अच्छा जी, तो आज हम लोग जो है बेटा एस्टर्स के बारे में पढ़ेंगे। ऑलराइट, तो व्हाट आर एस्टर्स? एस्टर्स आर बेसिकली ऑर्गेनिक कंपाउंड्स दैट कंटेन द फंक्शनल ग्रुप सी डबल ओ। ठीक है, व्हाट इज दिस फंक्शनल ग्रुप? अगर इस फंक्शनल ग्रुप को हम लोग साइड पे लिख के देखें तो द फंक्शनल ग्रुप लुक्स लाइक दिस। राइट, ठीक है, और फिर इस साइड भी कार्बन चेन होती है एंड देन इस साइड भी कार्बन चेन होती है। दिस इज द कंफर्मेशन ऑफ द प्रेजेंस ऑफ एस्टर्स। ठीक है, तो एस्टर्स की प्रेजेंस की कंफर्मेशन ये है पहला। सही है, तो दिस कंफर्म्स द प्रेजेंस ऑफ एस्टर्स। अब जो मेन बात है वो क्या है कि एस्टर्स की फिजिकल प्रॉपर्टीज क्या होती हैं? दे आर स्वीट स्मेलिंग, दे आर कलरलेस, दे usually do not dissolve in water. All right, they are usually found in flowers. अगर किसी को ये बात बताओ, esters are usually found in flowers. Flowers की जो characteristic fragrances होती हैं, majority of them are due to the presence of esters. ठीक है, तो esters are having that fruity smell. ठीक है, and the name of every ester is in the form of alkyl alkanoate. If we talk about naming esters, तो उनके जो नेम्स हैं वो जिस फॉर्म में होते हैं उस फॉर्म को अल्काइल अल्कानोएट कहते हैं। ठीक है, तो लेट्स जस्ट टेक अ न्यू पेज। Let's go to templates. Naming esters। ठीक है, esters contain two parts in their names। ठीक है, तो esters के जो names होते हैं वो दो पार्ट्स में ब्रेक हुए हुए होते हैं। ठीक है, सही है। पार्ट वन इज अल्काइल, दिस पार्ट इज ड्रिवन फ्रॉम द alcohol which the ester is made from। And the second part sounds like alkanoate। The second part sounds like alkanoate, and this part is driven from the carboxylic acid which the ester is made from। which the ester is made from। ठीक है, सही है। तो जिस कार्बोक्सिलिक एसिड से वो एस्टर बना होता है उसकी वजह से नाम में अल्कानोएट आता है, एंड जिस अल्कोहल की वजह से एस्टर बना होता है उसमें अल्काइल आता है। ठीक है, फॉर एग्जाम्पल, ठीक है, इफ यू टॉक अबाउट एन एग्जाम्पल, एन एस्टर made from, let's say, ethanol and propanoic acid will be called ethyl प्रोपानोएट। ठीक है, तो एक एस्टर जो कि इथानॉल और प्रोपानोइक एसिड से बना होता है, दैट एस्टर इज कॉल्ड इथाइल प्रोपानोएट। राइट, आई होप दैट मेक्स सेंस। एस्टर मेड फ्रॉम इथानॉल एंड प्रोपानोइक एसिड इज कॉल्ड इथाइल propanoid। All right, similarly, If you are given the name of an ester, you can decipher which alcohol and which carboxylic acid it could be made from. For example, the ester butyl methanoate must be made from what should it be made from? Butyl means butanol, and methanoate means methanoic acid. All right, it should be made from butanol and methanoic acid. This is how you name ester, and this is how you can decipher which alcohol and carboxylic acid the ester must be made from. Okay, I hope that makes sense. This is all that I had to explain other than what is written over here. Okay, the alkyl part describes the alcohol. All right, the alkyl part describes the alcohol used to make them. The alkanoate part describes the carboxylic acid. All right, production of ester. Now let's talk about how esters are produced. Producing an ester is called esterification. The reaction is also called condensation reaction because during the production of ester, during the reaction between alcohol and carboxylic acid, water molecules are produced, water molecules are released. So it's also called a condensation reaction, all right? Because water molecules are yielded, water molecules are produced. Okay. Next, we have ester is produced when alcohol is warmed with carboxylic acid in presence of few drops of sulfuric acid. So we use sulfuric acid as catalyst, especially as a dehydrating agent. All right. So it is specifically used as a dehydrating agent. It helps in the removal of water molecule from alcohol and carboxylic acid. All right. Now the very next thing. The next thing you need to know about esters is that whenever you react carboxylic acid with alcohol, the OH from the carboxylic acid and the H from the alcohol is removed to make water. What? Whenever we make carboxylic acid and alcohol, the OH is always removed from the carboxylic acids and the H is removed from the alcohol, all right, to make water. This is always the case, all right. And then the oxygen of the alcohol that is remaining is joined with the carbonyl carbon. This is called the carbonyl carbon. It's called carbonyl because it is the carbon double bond oxygen carbon, right? It is this oxygen is joined with the carbonyl carbon. And when the carbonyl carbon joins with the oxygen, we see an ester linkage forming. We see an ester linkage forming. Now an ester linkage is formed. And if you look at this compound, you can decipher that this compound is ethyl methanoate. This compound is ethyl methanoate. How do I know that? बेटा देखो, whenever we write the name of ester, we write the alcohol first and then the carboxylic acid. But usually when we write the chemical formula, in the chemical formula we are writing carboxylic acid first and alcohol next. Why is that? Why do we write carboxylic acid first? For one, it makes it look straight. It makes it look so that it doesn't look weird. Otherwise you'd have to write this backwards, and when you write this backwards it doesn't look natural. It looks natural when we write carboxylic acid first and then alcohol next, but it is completely fine if you write it the other way around. Like, for example, if you were to write carbon, carbon, hydrogen, 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 OH plus HOC double bond OH. If we were to write it this way, ethanol and methanoic acid, this would also be considered correct. There is nothing wrong with it. The hydrogen from the alcohol and the OH from the carboxylic acid, they will be joined to produce water, and then the oxygen will join with the carbon. But to me, it looks unnatural. I tend to, and most of the students also tend to write down carboxylic acids first and then alcohols. Okay, acha. Whether they are writing carboxylic acid first or alcohol later or whatever the situation is, if they write a formula, and if you are given a formula, for example, if you're given this formula, carbon, 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 hydrogen, 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 all these are hydrogens, and then you are joined with a compound, and it's got carbon, it's got another carbon, let's say. Okay, this is your compound. I have missed one thing. I will write it down, don't worry about it. Let's just move it a little bit further. There should be an oxygen over here, right, to make it an ester. All right, so now it is an ester linkage. And if someone asks you to give me the name of this compound, how can you name this compound? Better, the trick is very simple. The trick is that to name, by looking at the formula, you break the carbon oxygen single bond, not the double bond, the single bond, right? You break the carbon oxygen single bond, right? Okay. The side which contains the carbon double bond oxygen is the alkanoate side. It is what? It is the alkanoate side. Now, because it contains three carbons, this side is called propanoate, right? And the side which does not contain the carbon double bond carbon is the alkyl side. It is the alkyl side. So over here there are four, so it is called butyl. So the name of this ester becomes butyl propanoate. I hope that makes sense. If anyone does not understand, please open your mic and let me know. ठीक है? सही है? So the name of this ester would be butyl propanoate. Why? It will be butyl propanoate because the butyl part is the side which does not contain the carbon double bond oxygen, and the alkanoate part is always the side which contains the carbon double bond oxygen. If someone asks you which carboxylic acid and which alcohol was required, so because the name is propanoate, propanoic acid was required and butyl, so butanol was required. I hope this all makes sense. ठीक है? And with that, esters is completed. There is nothing else in esters. ठीक है? Only you need to know how esters are named and what alcohol and carboxylic acid is required to make an ester. And by looking at the chemical formula, you should be able to know which ester it is. ठीक है? So, like for example, if this is the disparate formula, you should be able to identify the uh, ester that is. With that, esters is completed, and then let's go to polymers or macromolecules, whatever you would like to call them. ठीक है? I believe I made a new one. Yeah. So this is polymers. ठीक है? So let's start polymers. Now, what are polymers, beta? What are polymers? Polymers basically they are macromolecular organic compounds. Macro means large, molecular means large molecule. Polymer bazate khud by itself is derived from two words, poly and mer. Poly means many, mer means molecule. Wherever you hear the word mer, it means molecule. Polymer means many molecules. Why do we call polymer polymer? Why does polymer mean many molecules? Because polymers, they're basically long chain organic compounds and they're made up of small repeating units. They're made up of small repeating units. All right. And the small repeating units are called monomers. Mono means one, mer means molecule. Mono means one, mer means molecule. All right. Polymers are generally of two types. There are two types of polymers, as we know, addition polymers and condensation polymers. The process of making polymer is called polymerization. That is also very simple. Now, the first type is addition polymerization. This is already studied in the chapter when I was teaching you alkenes. However, if you have forgotten it, then there is no worries. We are going to revise it. Addition polymerization is when the carbon-carbon double bond breaks. When the carbon-carbon double bond breaks, and the alkene molecules, because addition polymerization occurs in alkenes, ठीक है? Alkene molecules join with one another. All right. So this is what is written over here. In addition polymerization, many alkene molecules join together at high temperature and pressure by breaking their carbon-carbon double bond and form one straight chain polyalkene molecule. Right. Like for example, if you look at this reaction, in this reaction, this bond is going to break, and the carbons on each side are going to have one free bond, right? Like for example, this carbon carbon double bond is going to break, only one of the two bonds is going to break. Double bond में से सिर्फ एक bond टूटता है, all right? And then both the carbons will have ability to extend arms on either sides, right? Now a similar alkene on the right would join with this carbon, and the similar alkene on the left would have joined with this carbon, and similarly many alkene molecules, one, two, three, four, five, all the alkene molecules, they will join with one another like this. Okay. And they will form that. All right. Now if you want to write the whole, if you want to look at the whole polymer, you can extract two things out of it. By looking at the whole polymer, you should be able to tell which monomer it is made from, and you should be able to tell what the repeat unit of this compound is. Now, what is the difference between monomer and repeat unit? We have written over here in exam. We are sometimes asked to draw monomers, while other times we have to draw repeat units. When drawing a monomer, we must always draw or highlight the double bond which would be present in the monomer before polymerization. All right. So whenever we are drawing the monomer, we must show the double bond. All right. And whenever we are drawing the repeat unit, we must never show the double bond but show the two extensions. We must never show the double bond but show the two extensions. We should show how carbon is going to extend, the alkene molecule is going to extend and join with other alkene molecules. I hope that makes sense. All right. So you should know how to draw a monomer and how to draw a repeat unit every time. The next thing, when polychloroethene, all right, polychloroethene, which is spelled polychlorethene, it's abbreviated to PVC. Previously, in old manuscripts, it is abbreviated to PVC because it's called polyvinyl chloride. It's called polyvinyl chloride. In an alkene, the position beside carbon, double bond wala, is the vinyl position. So this is also the vinyl position. All right. So it's called vinyl chlorine, right? This is a vinyl chlorine. So polyvinyl chloride, because many alkenes, polyvinyl chloride means the chlorine is joined on the vinyl position of the alkene. Okay. Now, for example, this is N-chloroethene. It's going to make polychloroethene PVC. All right. So chlorine have a structure में instead of hydrogen. Instead of all hydrogens, we just have a chlorine in the structure. All right. Why is it important? Because this is how we make plastics. All right. PVC polymers are very famous as they are the major components of plastics. All right. If you want to further know, then you should know that PVC is of two types: high density polychloroethene and low density polychloroethene, or PVCs. ठीक है, तो high density and low density polymers are of two types. ठीक है, तो high density are those that are very hard and they will sink in water. Low densities are those that are very soft and they will float in water. For example, shopping bags are low density, but water pipes are high density. ठीक है. They are relatively inert. All plastics. अच्छा, uses and advantages of plastics की बात हो रही है. The chemical nature of plastics have promoted their worldwide use greatly. They are insoluble in water for one. They are relatively inert. They do not react. Sometimes they are sturdy and tough, while other times plastics are made to be soft and flexible. This is because some plastics are low density plastics used to make products such as plastic bags. Other plastics are high density plastics and are used to construct waterproofing products and PVC pipes. Disadvantages of plastics. In exams, they don't ask you for the advantages usually, they ask you for the disadvantages, and there are two. You need to remember two disadvantages of plastics. All right. The two disadvantages of plastics are they are non biodegradable. They are non-biodegradable. All right. So when we say they are non-biodegradable, it means that they cannot be put in landfill sites because they will only accumulate it for hundreds of years without decomposing. Right. Landfill sites are those places where we bury all the garbage so that it decomposes, and we can make fertilizer out of it. Or if we don't want to make fertilizer, it's just decomposing. So a place where we decompose all the organic waste matter. For example, the leftover peels of fruits, the leftovers of vegetable, leftover of food, bones, etc. ठीक है? These things, they have the ability to decompose by the action of bacteria and fungus, the natural decomposers. However, they can't decompose plastics. Plastics are something that cannot be decomposed. They're non-biodegradable. The definition of non-biodegradable is also very important as well. It is something that cannot be decomposed by action of microorganism. That is what you have to write, by action of microorganism. All right. Anyways, so they accumulate. That is the first thing, and then the second thing is they pollute. So if we can't throw them in landfill sites, then the second thing we can choose to do with plastics is burn them. Now, burning them is what is usually preferred because burning plastic produces heat. That heat can be utilized to make electricity. All right. However, burning plastic, meaning incineration of plastic, will result in production of carbon dioxide as well. So, first of all, what is incineration? Incineration involves complete burning of a substance in presence of oxygen gas. We should avoid incinerating plastic as it leads to production of many harmful and toxic gases such as carbon dioxide and hydrogen chloride. If plastic contains chlorine, it will produce hydrogen chloride HCl on burning. HCl is so toxic that if it goes in your lungs, it will make your lungs watery, meaning your lungs will be filled with liquid fluid. Water से भर जाएंगे lungs, and you will feel like you are drowning and you might die. ठीक है, सही है. So this is a severe condition of pneumonia. So, your lungs will fill with fluids if hydrogen chloride is inhaled. Therefore, hydrogen chloride is considered extremely toxic. Therefore, we should be very cautious before burning plastic. We should know that this plastic does not contain any chlorine derivatives. All right. I hope that makes sense. Hence, disposal of plastics is avoided. Instead, we should reuse and recycle all the used plastic supplies. We should reuse and recycle all the plastic supplies. These are the two things. All right, one very good way of recycling plastics is called the repolymerization of plastics. All right, repolymerization of substances. It is not generally used in plastics much. It is used more in condensation polymers. I will tell you why it is the repolymerization part is not considered to be used in plastics much. For plastics, all we can do is we can just reuse the plastic after washing it. Like, for example, take a container. Once you've used the container, just rinse it with clean reuse. I'm sure the Pakistan household families know that what we do with plastic boxes, especially of ice creams and stuff. They go in for other storage devices, right? So those are good things. We should reuse and reutilize the plastic products. We should not just dump them. It just increases pollution. Okay. Next, we have condensation polymerization. What is condensation polymerization? It is the polymerization in which functional groups of monomer join together to yield a polymer in many small molecules, such as water. All right, two types of condensation polymers there are polyamides and polyesters. We know both water polyamides and water polyesters. ठीक है? Polyamides are formed when many monomers containing carboxylic acid COOH functional group and amine NH2 functional group join via condensation, produce many amide linkages called polyamides. They produce many amide linkages called polyamides. Right. So polyamides are formed when many monomers containing carboxylic acid COOH functional group and amine NH2 functional group join via condensation reaction. Right. So what is polyamides? Polyamide is when carboxylic acid joins with the amine group. It produces the amide bond. Many carboxylic acid join with many amines, produce many amide bonds, therefore called poly. So polyamides are made when many carboxylic acid and many amines join together. All right. Example of polyamides in our syllabus is nylon. You should always remember that nylon is a polyamide, that it contains the amide linkage. It contains the amide linkage. Now, nylon is a synthetic polyamide made from many dicarboxylic acids and diamines. What is it made from? Dicarboxylic acids and diamines. What are dicarboxylic acids? Basically, carboxylic acids which have a carbon chain in the middle and carboxylic acid functional groups on both sides. So, for polymerization, condensation polymerization to take place, every molecule which wants to take place in condensation polymerization must have at least two functional groups. It must have at least two functional groups so that it can form chain, right? To make a chain, you need to bond from two sides. That is why a minimum of two functional groups are required every time you see a condensation polymer. All right. And carboxylic acid and amine, amongst them, the OH of carboxylic acid and the H of amine. Over here, we do not have alcohol. They join together to produce water. They join together to produce water. Okay. So that is very important. You can see over here that this bond breaks, the carbon oxygen bond breaks, and the hydrogen nitrogen bond breaks, and then the carbon nitrogen bond forms. All right. The carbon nitrogen bond which forms is the amide bond, and this whole thing is the characteristic amide linkage. All right. The side with carbon double bond oxygen tells us the carboxylic acid, and the side with amine tells us the amine. All right. And then we also have water. And this, what I have drawn, is a repeat unit. If you observe carefully, this is a repeat unit. It must be repeated many number of times. All right. And it is good practice to always draw repeat units inside of brackets. It is always good practice to draw repeat units inside of brackets. All right. So this is one good way of making a condensation polymer or a polyamide. Okay. Now, when making polyamides, the OH is removed from carboxylic acid while H is removed from the amine group. All right. The OH is removed from carboxylic acid and the H is removed from the amine group. That is how you make polyamides. Now let's talk about polyesters. We're now going to talk about polyesters. Poly means many. Esters we have just studied today again. Esters are compounds that are made from carboxylic acid and alcohol joining together. So polyesters would mean that when many functional groups of carboxylic acid join with many functional groups of alcohol to produce many ester bonds, then it is called polyester. So polyesters are formed when many monomers containing carboxylic acid functional group and alcohol functional group join via condensation reaction produce many ester linkages called polyesters. Okay. The example is PET. The example for polyesters is PET. Previously, we used to know this as terylene. All right, but the syllabus has now changed. We now call it PET. Why do we call it PET? Because it is industrially considered that. ठीक है. Terylene is only one type, PET is of many types. ठीक है. PET के आगे जो है एक branch of products हैं which can each one of them can form separately. ठीक है. PET stands for polyethylene terephthalate. It is a synthetic. The spelling of synthetic is a little questionable. Wait. Synthetic. All right. So the synthetic alcohols. All right. So the PET is made from many dicarboxylic acid and many diols. Of course, it's going to be produced from carboxylic acid and alcohols. Now, di because two, right? Two carboxylic acids per molecule. This molecule contains two carboxylic acid, and this molecule contains two alcohol functional group, two OH functional groups. All right. So the rule is very simple and similar. H from oxalic acid and the H from alcohol, they join to produce water molecule, and then the carbon joins with oxygen every time. Okay. So over here as well, the H will remove and the OH will remove. So beta, in exam as well, whenever they ask you to draw the repeat unit, you are going to have to remove the OH and the H from the carboxylic acid and alcohol of the far corners one as well. All right. यहाँ पे यानी कि आप OH लिख के नहीं छोड़ सकते. It will be considered wrong. ठीक है. You have to remove and you have to show these open bonds. You have to show these open bonds. ठीक है. उसके बाद during ester formation, carboxylic acid lose their OH negative while alcohol lose their H. Not OH negative, sorry, they just lose their OH. एक बात याद रखिएगा बेटा कि over here this is not hydroxide, this is hydroxy या hydroxyl. ठीक है. This is not hydroxide, it is not an anion, it does not contain any charge, it is hydroxy or hydroxyl, not the ion. ठीक है. I hope that makes sense. Now, advantages of condensation polymerization. Why are condensation polymers better than addition polymers? That is a good question. Okay. All living organisms are essentially made of protein. We are all made up of protein. You are made of protein. I am made of protein. Everyone is made up of protein. Proteins are polyamides. We should know that proteins are polyamides. They are made from amino acids. Amino acids contain amino groups and carboxylic acid groups. They join to form peptide bonds. Peptide bonds are basically peptide bonds are basically amide bonds. Peptide bonds are amide bonds, right? तो proteins are polyamides made from many repeating monomers called amino acids. Therefore, most condensation polymers are biodegradable. Most condensation polymers, they are biodegradable, which means they can be decomposed by action of enzymes or microorganisms, right? Because proteins are made inside our body, there are ways to digest them. Digesting का मतलब degrade them या decompose them. Therefore हम ये कहते हैं कि condensation polymers, because they contain the same kind of bonds as proteins, we are able to break their bonds as well, because digestion just means breaking bonds. Digestion से हम bonds ही तो तोड़ते हैं, right? तो decomposition के अंदर भी हम bonds ही तो तोड़ते हैं. तो bonds कौन से टूट सकते हैं? Condensation polymers वाले, because their bonds resemble the bonds of our body. ठीक है. Therefore condensation polymers do not accumulate in landfill sites. Since it is easy to break the condensation polymers down by action of enzymes, we employ a tactic on them called repolymerization. Because basically we are saying, because condensation polymers are biodegradable. Condensation polymers are biodegradable. Let me just write this line down over here as well. Condensation polymers are biodegradable. Condensation polymers are biodegradable. All right. So condensation polymers are biodegradable. This is something important and it makes sense. ठीक है. They are biodegradable. They can be decomposed by action of bacteria. Well, I should put the word most. Most condensation polymers are biodegradable. ठीक है. But well, it's all right if we write this as well. Okay. Next, the final thing that we need to know about repolymerization or condensation polymers is that condensation polymers are repolymerized, uh, and they can be broken down into their monomers, meaning we can get the monomers from these polymers again, and then we can use those monomers to make new and other different useful polymers, right? So condensation polymers are never wasted. मतलब उनके स्ट्रक्चर के भी यूज का अगर यूज खत्म हो जाए, स्ट्रक्चर का भी यूज खत्म हो जाए, we just break them down and make a new structure out of them, right? Because we can break them down, because the bonds can break. However, plastics जो थे, जो के एडिशन पॉलीमर्स थे, they cannot be broken down like that. Therefore we say plastics cannot be repolymerized, they are non biodegradable. All right, I hope that makes sense. And with that, the polymers chapter is also completed.